Article 370.28 specifies the minimum lengths of pull boxes for electrical systems, including raceways for electrical conductors. It applies to pull boxes installed in raceways for electrical conductors, such as conduit or cable trace. Article 800.48 specifically addresses communications raceways and does not require minimum lengths for pull boxes. It only requires that communications pull boxes have sufficient length to accommodate the number of cables and the pulling tension required. Therefore, the requirements from Article 370.28 do not apply to Article 800.48 pull boxes. In the situation described, there is no need to add the additional sizes of conduit to the 18-inch minimum length specified in Article 370.28. You should only provide enough length in the pull box to accommodate the number of communications cables and the pulling tension required. Let's delve deeper into the specifics of these articles. Article 370.28 concerning pull and junction boxes, conduit bodies, and handhole enclosures outlines detailed requirements for sizing these enclosures in various scenarios within electrical systems. These requirements are primarily focused on ensuring adequate space for conductors to be installed and maintained safely, minimizing stress on the conductors during pulling and ensuring proper heat dissipation. The article distinguishes between straight pulls and angle or U-pulls, each having its own calculation method for determining the minimum dimensions of the enclosure. For straight pulls, the minimum length of the box must not be less than 8 times the tray diameter of the largest raceway entering or leaving the box in a straight pull. This requirement is crucial for providing sufficient space for the conductors to pass through the box without undue bending or strain. For angle or U-pulls, the dimensions are calculated differently to accommodate the change in direction of the conductors. The distance between each raceway entry and the opposite wall of the box must not be less than 6 times the tray diameter of the largest raceway in a row. Additionally, the sum of the diameters of all raceways entering one side of the box must be within 75% of the box width to maintain proper spacing and accessibility. Article 370.28 also includes provisions for situations where different sizes of raceways are used, requiring calculations based on the largest raceway to ensure adequate space for all conductors. Furthermore, it addresses the use of conduit bodies, which are smaller enclosures used to provide access to conductors at bends or junctions. These conduit bodies must be of sufficient size to accommodate the conductors and any splices or terminations within them. Handhole enclosures, typically installed underground, are also covered by Article 370.28 with specific requirements for their construction and accessibility. These enclosures must be designed to withstand the environmental conditions and provide safe access for maintenance and inspection. In contrast, Article 800.48 focuses specifically on the installation of communications wires and cables within raceways. This article recognizes the unique characteristics of communications cabling such as fiber optic cables and data cables, which have different bending radius requirements and sensitivity to damage compared to electrical conductors. Unlike Article 370.28, Article 800.48 does not mandate specific minimum dimensions for pull boxes used in communications raceways. Instead, it emphasizes the need for sufficient space to accommodate the number of cables being installed and the pulling tension required to avoid damaging the cables during installation. The primary concern is to ensure that the cables can be pulled through the raceway without exceeding their minimum bending radius or experiencing excessive strain. This is particularly important for fiber optic cables, which are highly sensitive to bending and tension. Article 800.48 also addresses the separation of communications cables from electrical conductors to prevent interference and ensure signal integrity. It specifies the minimum distances that must be maintained between communications cables and power conductors, as well as grounding requirements to minimize the risk of electrical noise and surges. The article also covers the use of specific types of raceways and fittings that are suitable for communications cabling, such as those with smooth inner surfaces to prevent damage to the cables during pulling. Furthermore, Article 800.48 addresses the identification and labeling of communications raceways and pull boxes to distinguish them from electrical systems. This is crucial for preventing accidental damage or modification of communications cabling during maintenance or renovations. In summary, while Article 370.28 provides detailed requirements for the sizing of pull boxes in electrical systems, Article 800.48 focuses on the specific needs of communications cabling and does not impose the same minimum dimension requirements. Instead, Article 800.48 emphasizes the importance of providing sufficient space and protection for communications cables to ensure their proper installation and operation. When working with communications raceways, it is essential to consult Article 800.48 and other relevant sections of the Code to ensure compliance with all applicable requirements. This includes considering the type of cabling being installed, the pulling tension required, and the need for separation from electrical conductors. Understanding the differences between these two articles is crucial for ensuring the safety and reliability of both electrical and communications systems. Now, let's consider a practical example to illustrate the application of these principles. Imagine a scenario where multiple groups of conduits, each containing communications wiring, are being installed in a commercial building. These conduits are routed through a series of pull boxes to facilitate the installation and future maintenance of the cabling. According to Article 800.48, the pull boxes used in this installation must be of sufficient size to accommodate the number of cables being pulled through them and the pulling tension required. However, unlike electrical systems, there is no specific minimum length requirement based on the diameter of the conduits. Instead, the focus is on providing enough space to prevent damage to the communications cables during installation and to allow for future access and modifications. In this example, the size of the pull boxes would be determined by factors such as the number of cables in each conduit, the bending radius of the cables, and the anticipated pulling tension. It is important to select pull boxes that are large enough to accommodate these factors without causing undue stress or damage to the cables. Additionally, the pull boxes should be installed in a manner that allows for easy access and maintenance. This may involve considering the location of the pull boxes, the orientation of the conduits, and the use of appropriate hardware and fittings. In contrast, if these conduits were being used to carry electrical conductors, Article 370.28 would apply, and the pull boxes would need to meet specific minimum length requirements based on the diameter of the conduits. This would ensure that there is enough space for the electrical conductors to be pulled through the boxes without exceeding their bending radius or experiencing excessive strain. The distinction between these two scenarios highlights the importance of understanding the specific requirements of the applicable codes and standards when designing and installing electrical and communications systems. Failing to comply with these requirements can lead to safety hazards, system malfunctions, and costly rework. Therefore, it is essential for electricians, technicians, and engineers to stay informed about the latest code changes and to apply them correctly in their work. In addition to the specific requirements of Articles 370.28 and 800.48, there are other general considerations that should be taken into account when selecting and installing pull boxes. These include the environmental conditions in which the pull boxes will be installed, the type of materials used in their construction, and the need for grounding and bonding. Pull boxes installed in wet or corrosive environments should be made of materials that are resistant to corrosion and moisture. This will help to prevent premature failure and ensure the long-term reliability of the system. The type of materials used in the construction of the pull boxes should also be compatible with the type of cables and conductors being installed. This will help to prevent galvanic corrosion and other types of material degradation. Grounding and bonding are essential for ensuring the safety of electrical and communications systems. Pull boxes should be properly grounded and bonded to prevent the buildup of static electricity and to provide a low impedance path for fault currents. This will help to protect personnel and equipment from electrical shock and damage. By considering these general considerations in addition to the specific requirements of the codes and standards, it is possible to design and install pull box systems that are safe, reliable, and compliant with all applicable regulations. Remember, always consult the latest edition of the National Electrical Code and any applicable local codes or regulations for the most up-to-date information and requirements. The NEC is updated every 3 years, and local codes may have additional requirements that are not covered by the NEC. Staying informed about these changes is crucial for ensuring compliance and avoiding potential safety hazards. Additionally, it is always a good idea to consult with a qualified electrical engineer or inspector if you have any questions or concerns about the design or installation of electrical or communication systems. These professionals can provide valuable guidance and ensure that your project is completed safely and in compliance with all applicable regulations.